Okay, now we move forward to the topics of stability and instability factors. There are two types of body. If we will consider whether the body will float out or whether the body will completely submerged in the liquid. If the body is completely confined in the liquid, definitely there is a state of the stability which is also required in order to say in a manner that it will not start to rotate itself with certain position. Like if I say that submarine sink down in the sea, okay, but it is not like that. Its upper part sometimes rotate down and come to the bottom side, and the bottom part is again rotate in such a manner that it becomes the top part. So again it's required some stability factors as well. So what is the condition for stability for this type of body? The condition for stability of body completely submerged in a fluid is that the center of gravity of the body must be below than the center of buoyancy. Now we can see here the center gravity of the body at which the whole body weight exert is here at this part, okay, and it is below than the point at which the resultant buoyancy force is acting on the body, and the resultant force of the buoyancy force definitely depend upon how much the specific weight of the fluid specific weight and the volume submerged or volume of the body. Definitely its complete volume is submerged in that way. So they had to maintain it in such a manner that once the center of gravity is below than, as I have told you, below than the center of buoyancy, the body will retain its position of whatever it has in upper part, or if a certain point is present in the lower part, it will retain its position in lower part. Although there may come some disturbance when it flow in the liquid, but although it will retain its position in that way. So this is the basic condition of stability for completely submerged body, and we will consider these type of body as they are stable. If these both points coincide to each other, definitely this is not the sign of the stability. Actually it becomes the sign of the neutral body, like it may rotate and even we don't know as which type of position it will gain. On the other hand, if the center of gravity point becomes higher than the center of buoyancy force, what will happen? The body will revert its position, like the upper part moves in such a manner it becomes a lower moves towards the lower part of the body, and the body completely rotates itself in that way. So again it will considered as the unstable condition of the submerged body. Then we have the stability of floating bodies. Okay, stability of floating bodies depends on so many factors. The condition which we can say here, a floating body is stable if its center of gravity is below than the matter center. And what is matter center actually? Let's suppose we have this type of floating body here in a particular liquid, which is partially submerged in the liquid and partially floating above the liquid. Let's suppose we have disturbed this particular body up to certain angle. Okay, so what happened? We comes to know that it will rotate itself around a fixed point. Okay, this fixed point retain its position, although whole body may rotate itself, or point displays with certain angles, like CG, center of gravity point, is present here and it displays with angle some sort of angle theta. Okay, so this point which is a fixed point and around which the body rotate itself, is the point which we so called as the meta center point. Okay, although there are other points as well, that's where the whole body center gravity exerted. Definitely we called it as a center gravity point, and there is a point at which the whole fluid applying buoyancy force, the resultant of buoyancy force acting on a particular point of the body, which we considered as center of buoyancy as well, which again depends upon the specific weight of the liquid and the volume which is submerged, volume of body which is submerged, not the complete volume of the body. Okay, so only the volume of the body which is submerged in the liquid or sink or displaced in the liquid. So there are other factors as well which we need to determine, which we need to understand. So I will explain you in whiteboards. Okay, in the figure you can see here that I have represent certain points, like this is the meta center point, this is center of gravity of the body where whole body weight concentrate, this is CB, the center buoyancy force point. Now there are certain factors influence this type of body. Okay, first thing is that if we take the distance from meta center to center of buoyancy, we will call it MB, meta buoyancy point. Okay, and if I will say that I am taking the distance from center of gravity to meta center, it is meta center height. Okay, which is YMC, meta center height. Okay, one more thing, that there are certain displacement which we took from the very bottom part of the body. Like if I am talking that the distance from bottom part to center of buoyancy, I will name is YCB, and similarly for center of gravity I will name it as YCG. On the other hand, if I will talk for MC, it will be YMC. So it can easily be understandable that YMC is nothing just equals to the point YCB and MB, okay, which meta buoyancy point, which is the height here between meta center to CB. And there are other relations through which we can determine MB, because MB can be determined as IXC over volume displaced. Once you have determined this, you can easily determine YMC. YMC is nothing just equals to YCB plus MB, as you can see it from the figure. So these are the some of the relations you need to understand, and easy to for you to, when you are analyzing the numerical. And IXE value you can determine by this chart. Okay, if the body has respective dimensions, you will utilize the similar value of IXE. Here only the procedure is described here, and a part of that, the most important thing which you need to understand is once you determine YMC, so it also describes your stability or instability. If YMC is greater than YCG, the body is stable. If YMC is less than YCG, the body is considered as unstable, and it can be rotate or revert out itself at any point. Okay, then we have a numerical. Okay, in the figure there is a flat board, and its weight is 150 kilonewton, and they have described some of the dimensions. We have to determine whether the board is stable in fresh water or not. So this is the figure. They have described the dimension in such a manner that one side is 6 meter in length and its width is 2.4 meters. Although we don't know the value, that how much it is, its volume synced within the liquid. Okay, so we will solve it. Okay, this is the figure of the body, and we know that this is the distance B, this is the length L, and this is, I named it X, that up to that much height it is synced up. And if I want to know the volume displaced by this solid body, will be equals to, definitely equals to it B multiplied by L, and the height at which only the body submerged within the liquid. Okay, a part of that, we also know the weight of the body. Okay, and the relations which we have to utilize, like FB is equals to a specific weight of the liquid, volume displaced, B is nothing, just equals to IXE VD. And for this particular case, you can easily determine what is the value of IXE for this particular figure. Okay, so now we first develop the equation. So here we can see that as weight is acting downward, so a buoyancy force is acting upward. So it will be equals to, in such a manner that FB will be equals to the weight of the body. And on the other hand, we know that it is equals to a specific weight of fluid, volume displaced, and all these things are equals to 9810 multiplied by volume displaced is equals to B, L and X. We know the value of B, 2.4. We know the value of L, which is equals to 6, but we have to determine the value of X, and it is just equals to the weight of the body, and the weight of the body is equals to 150 into 10 raised to the power of 3 newtons. So from here we can determine the value of X by equating this equation, and the value of X is 1.062 meters. Okay, so for MB we need to determine the value of IXE, and IXE is just equals to 1 over 12, value of L is 6, B value is 2.4 whole cube, and it will just equals to 6.912 m power of 4. Okay, so we know IXE value, we know we can determine VD value now. VD value is simply just equals to all these factors, and by calculation we comes to know that VD is equals to 15.293 cubic meter. Now you can determine MB by taking the ratio of this value and VD value. So we comes to know that MB is just equals to 0.452 meters. So the height of MB is equals to this. A part of that, we also need to determine the center point of YCB, center of buoyancy, and definitely it will be equals to half of x. Why? Because this is the height at which the body is sink within the fluid. Okay, so the center point from bottom to where the force is exerting the buoyancy force, I mean the resultant force of the buoyancy force exerting on that particular point, which is the vertical distance, will be equals to YCB, and it exactly be equals to x divided by 2, and which is nothing, just equals to 0.531 meters. Now we can easily determine YMC. YMC is nothing, just the sum of MB plus YCB, and it is now equals to 0.983, which is greater than YCB value. So body is stable. Body is definitely considered as stable. So this is a very simple numerical through which we can determine whether the body is stable or not, the floating body is stable or not. Then there is a degree of stability which is described by the meta-center height, and the meta-center height is the distance of the meta-center with center of gravity. So greater this distance, if the distance is much greater, the body is considered as too much stable, and it's if they are come nearer and nearer to each other, these 2 points, or the meta center height is reduced, the body is considered that it is moving in near to instability. Although the degree of stability can be determined by the meta center height, which is represented by mg, okay, and it is equals to YMC minus YCG. YMC is the distance from bottom part to meta center point, and YCG is the distance from bottom part of the body to the center of gravity of the body. So once you subtract out, again you will get the distance from the distance between the meta center and center of gravity. If this distance is greater, the greater will be stability you will find in the body. These are some of the standards you need to just consider and go through it. It's not very important factors, but these are the standards we use to design in a particular ship, and we need to balance out them in order to make sure that the ship will stable in the river or sea. Okay.